A 67.2 gram sample of a gold and palladium alloy contains 2.49 times 10 to the 23rd atoms. What is the composition by mass of the alloy? Okay, so what is given in the problem? 67.2 grams alloy. And 2.49 times 10 to the 23rd atoms alloy. What is wanted is composition of the alloy by mass specifically of alloy. Okay, so I need to figure out what composition by mass is, first of all, so I can figure out personally what I'm solving for. So composition by mass of alloy means that the percentage of mass each particle or thing the alloy is made up of gave to the whole mass, for example. So alloy is equal to gold plus palladium, according to this problem, this particular sample. So I know that it's made up of two things. So for the composition, I want to figure out the grams of gold divided by grams of alloy and multiply that by 100. And the same thing for the palladium. However, since you know the total has to be 100, you can find one percentage and then subtract from 100 to find the other percentage. So basically your goal is to solve for mass of gold and palladium. Alrighty, so you're given grams and atoms of the entire substance, the entire sample. You know that you can say that grams of alloy is equal to grams of gold plus grams of palladium. So a nice thing to do, or a good thing to do, is just to create an equation and plug in what you know. Let X be gold and Y be palladium. And then this comes out to be 67.2 grams is equal to X plus Y. Okay, well, I also have given the amount of atoms that it consists of, and that's pretty important. So what would make sense to me is, since I want to end up with grams, I'm given atoms. I know that I can use a conversion factor to go from atoms to moles and then moles to atoms. So what I'm going to do is kind of interject here, convert total atoms to moles, which comes out to be 2.49 times 10 to the 23rd atoms divided by the Avogadros number to find total moles. And that number comes out to be, if you plug it into your calculator, 0.4136 moles. Okay, this represents total moles. So then, total moles, moles of alloy, is also equal to moles of gold plus mole of palladium. So 0.4136 moles is equal to X plus Y. Now we have two equations, one in grams, one with moles. Since we want to figure out how many grams we have, it's good to go to moles because you can always use molar mass later to go to grams. So take this equation and separate for one variable. It doesn't matter which one, just one of them. I personally decided to subtract X from both sides and find that Y is equal to 0.4136 moles minus X. So let's say this was my second equation, this was my first, then I go back up here. So I get, let's change the color, 67.2 grams is equal to, since I want to be in masses and I don't have the mass, I only have molar mass, I'm going to write in my molar mass of gold. So changing that to a mass equation, 196.97 grams per moles times X plus 106.42 grams per mole times Y. Those were the molar masses from periodic table. Now plugging in the variables that I solved for, 196.97 grams per mole, making the equation in terms of X, and then 106.42 grams per mole, multiplying that by 0.4136 moles minus X. Expanding that equation then just becomes algebra. The moles here cancel and you'll be left with grams. 44.0153 grams minus 106.42 grams per mole times X. And now you have numbers with no variable and numbers with a variable, so you just clump together your X's and the numbers with no X's, which gives you 23.1846 grams equal to 90.55 grams per mole times X. And then you can divide by 90.55 grams per mole on both sides. And you'll see that your grams cancel and X is equal to 0.2560 moles. X is gold. So then, since you want percent composition, if you go back up here and you realize that you need grams of AU, now you have moles. So then you take your 0.2560, let's be really specific, moles of gold, since you said X was gold, and divide it by the molar mass, multiply it by the molar mass to find just the grams. 196.97 grams divided by moles, which then cancels out your moles, and you're left with 50.4328 grams of gold. So then percent composition is mass of gold over mass of alloy, which is 50.4328 grams divided by 67.2 grams times 100, and that comes out to be 75% for gold. Then for the percent composition of palladium, you know that it has to be 100, so you take your 100 minus 75, which gives you 25% of palladium. So the alloy sample is made up of 75% gold and 25% palladium. So with these types of problems, it looked like it was going to be nice and simple because it was just one or two sentences, but it turned out to be a lot more work. You knew that you have a total mass of 67.2 of this sample, and that this sample is made up of gold and palladium. Then you also knew the amount of mass in total, which atoms in total, which is also only made up of palladium and gold. When you have those types of problems, what is really useful is to create equations like these, and then assign the variables and rearrange for just one variable so that then you can plug it in to solve for just one of them in the unit that you desire. And then usually it's just the total minus the unit that you solve for to get the other one. You could have stayed in atoms here instead of moles, and done this work exactly the same. It would just been more exponents because of atoms being such a small number, but worked the exact same way. So what we did here, just as a real recap, we know that 67.2 grams of alloy was made up of grams of gold and grams of palladium. Since you wanted the composition, to find the composition of the sample, you needed the percent of gold and percent of palladium, which would be grams gold divided by grams alloy times 100, grams palladium over grams alloy times 100. So you knew that you needed to go to grams. So I decided that I would like to go to grams from molar mass and get rid of all the atoms in the small numbers. So I took the 2.49 times 10 to the 23 atoms of alloy and converted to just total moles, which was 0.4136 moles. Then I knew that since it's still just the moles of the entire sample, that's the same equation. Moles total is equal to the moles of the gold and moles of palladium. I rearranged to just solve for one variable. Then my mass is equal to the mass of both of my gold and palladium, but since I needed mass, I used the mole equations and variables that I solved for and plugged it in with the molar mass so that the appropriate units would cancel. Did some algebra and expanded and figured out that I have 0.2560 moles of gold in this sample. Used the molar mass to find just the mass of gold, divided by the total, found the percent, subtracted that from 100, and found the percent of the palladium.